I'm Meena. Today's topic is about Introduction to Connectives. I'm currently studying in Sri Venkateswara College of Engineering, pursuing my bachelor's in the CSE with the specialization of cybersecurity. So let's get into the topic. Connectives are the building blocks of logic. They combine propositions to create new complex statements. Connectives allow us to express relationships between prepositions such as conjunction, disjunction, negation, and implication and equivalence. Coming to the first topic, that is AND gate, it is also known as conjunction. A conjunction connectives often represented by a symbol AND is also used to combine two prepositions, creating a new preposition that is true. Only when both of the original prepositions are true. It is commonly known as the AND operator. For example, if the preposition the sky is blue is true and the preposition the glass is green is also true, then the conjunction the sky is blue and grass is green is true. However, if either of the original preposition is false, then the conjunction will be false. Which means if there are two true statements, then the conjunction will also be true. If either of the one is false and other is true, then the conjunction will be false. So the second topic is about disjunction. The disjunction connectives combines two prepositions, creating a new preposition that is true. If at least one of the original preposition is true, this is often called OR operator. For example, if the preposition the sun is shining is true and the preposition it is raining is false, then the disjunction the sun is shining or it is raining is still true. If both the original prepositions are true, the disjunction is also true. The disjunction is only false when both the original prepositions are false. The disjunction is a fundamental concept in logic and it allows us to express a wide variety of relationships between the prepositions. To the third topic, that is negation. It is also known as NOT gate. The negation connective denoted by the symbol not reverses the truth values of a preposition. If the preposition is true, its negation is false and it is vice versa. Negation is often referred to as the not operator. It is a fundamental concept in logic as it allows us to express the opposite of a preposition. For example, if the preposition the sun is shining is true, then its negation will be the sun is not shining, which is false. Similarly, if the preposition it is raining is false, then the negation it is not raining is true. So it is basically opposite operator. Next concept is about conditional. It is also like if then condition. The condition connective often represented by the symbol arrow. If it is also known as if then operator. It combines two prepositions forming a new preposition that is true unless the first preposition is true and the second preposition is false. For instance, if the preposition it is raining is true and the preposition the ground is wet is also true, then the conditional if it is raining then the ground is wet is true. However, if it's raining is true, but the ground is wet is false, then the conditional becomes false. Coming to the next topic, that is biconditional if and only if. The biconditional connective symbolized by two arrows facing towards opposite direction or expresses logical equivalence. It combines two prepositions and is only true when both the propositions have same truth values. This is often referred as the if and only if operator. Essentially, it states that one proposition is true if and only if the other is true. For instance, if the proposition the sky is blue is true and the proposition the grass is true is also true, then the biconditional statement will be if sky is blue, if and only if the grass is green, is true. However, if either preposition has a different truth value, then the biconditional will be false. If the biconditional connective is crucial for expressing mutual dependence between preposition and play a key role in reasoning. Now let's learn about truth tables for connectives. First is AND gate. A truth table for conjunction shows truth values for the compound preposition P and Q for all possible combinations of truth values for P and Q. It illustrates that the compound preposition is true only when both P and Q are true. Disjunction, which is OR gate, a truth table for disjunction displays the truth values of P or Q for all possible truth values of P and Q. It demonstrates that the compound preposition is true unless both P and Q are false. Third is negation not. A truth table for negation shows truth value of not P for all possible truth values of P. It indicates that the truth values for the negation is the opposite for the original proposition. If P is true, then not P is false, and vice versa. Next is conditional if then. A truth table for conditional shows the truth values of if P then Q for all possible combinations of truth table for P and Q. It illustrates that the compound preposition is false only when P is true and Q is false. Coming to the next topic, that is tautologies and contradictions. Tautology, a proposition always true regardless of truth values of its components. Example, it is raining or it is not raining. Contradiction, a preposition always false regardless of truth values of its components. Example, it is raining and it is not raining. These concepts are essential for understanding logical validity and soundness of the arguments. Tautologies can be used to prove other propositions and identify logical equivalence. Contradictions indicate inconsistency or an error in reasoning. Next is practical applications of connectivities. Connectivities are vital in logic but are also have real world applications in various fields. In computer programming, they are essential for creating complex conditions and controlling program flow. For instance, in a video game using and or allows for multiple outcomes. Based on player actions in the databases, they will help to refine search queries for specific data sets. Connectives are crucial in formal reasoning, allowing for logical analysis of arguments and making sure they are valid and sound. They are also widely used in artificial intelligence, enabling machines to perform logical reasoning in cybersecurity for network intrusion detection. Thank you for watching.